I welcome you all to this wonderful lesson. So this is an interesting topic that I want us to look at. So even as I teach you this particular topic, I guess you are going to follow through. It's a continuation from where we ended from. So this is a resistance, and we have to understand the definition for resistance itself. You need to know what resistance is. Last time we were looking at current. I guess most of you had to see how I was doing those calculations. I gave you an exercise of which I revised through. So whenever we are talking about resistance, this is resistance in a what? In a circuit. So even our definition will be based on this part because it is in a what? In a circuit. How do we define resistance in a circuit? This is just the opposition. So we are saying that it is the what? It is the opposition of opposition to the flow of charge. It is just the opposition to the flow of charge. This is what resistance is. So if I tell you what is resistance, resistance is just defined as the opposition. This is the opposition to the flow of charge. And the SI unit for resistance, the SI unit is ohm, like this. The symbol is this symbol. The symbol for ohm like this. Have you seen that? So this is the SI unit is ohm, and the symbol is that one. So that's what we need to understand. You discover that some components in a circuit, such as bulb and heater, have a certain resistance. So each electric appliance gets to have a resistance. There is that opposition to the flow of charge. So a device which provides some resistance in the circuit is called a resistor. So I want you to understand that the device, this device can be a heater, it can be a bulb, as long as it is doing what? It is providing, so I'll say a device which provides some resistance. So a device which provides some resistance in a circuit, in a circuit is called what? In a circuit is called, I'll say, is called what? Is called a resistor. We get to call it a what? A resistor. That is a resistor. So a resistor is a device that gets to provide some resistance in a circuit. So a resistor which can vary the resistance is called a rheostat. So you also need to understand, aside knowing this, you also need to know that a resistor, so I'm saying that a resistor which vary resistance, which does what? Which vary resistance. I'll say a resistor which vary resistance is called, what do we call it? What is the name that is given to it? So the name is what? What is the name of this? The name we are calling it what? The name that is given to this. So the name that is given to this is called what? So the name is what? This is the name that is given to that, rheostat. This is the name. So we get to call it by that. A resistor which vary resistance in a circuit is called a rheostat. So that is a name that you have to understand. And if you are given a question, you now discover that it is at this point now where we are now going to introduce some formulas and some circuit diagrams. It is at this point where we get to introduce those things. So you discover that resistance is equal to voltage over current. This is a particular formula we get to use. Or we can say voltage is equal to current times resistance. If you make resistance the subject of the formula, that's when we are coming up with this particular formula. So this relationship that is there, this relationship that is here, so a relationship that is here or this relationship that is there. So I would say this relationship is called what? This relationship. So this relationship is called, what is the name that is given to it? It is called the Ohm's law. I guess you now, you've heard of this somewhere at grade 9 where we looked at the Ohm's law. What is Ohm's law? These are questions that even used to come in an exam. Even now they do come. They'll ask you, state Ohm's law. So Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference. So obviously current is directly proportional to potential difference. This is the voltage that is there. So Ohm's law states that you can explain it in that way. It is just one and the same. Don't be confused. It is just one and the same thing. So if you want, you can say that Ohm's law states that current is inversely, resistance in a circuit is inversely proportional to the current, but directly proportional to the what? To the voltage or the potential difference. You are just explaining these formulas mathematically. So this is the common one where we say Ohm's law states that current, maybe there's someone that wants to write this one. So whenever we are talking about Ohm's law states that it states this is what states that current, so it states that current flowing, so I guess you are able to see this, current flowing in a circuit, that is flowing in a what? Current flowing in a what? In a circuit. So current flowing in a circuit is directly, so I'll say is directly, I'll say it is directly what? Directly proportional. So directly proportional, this is what I'm going to say, directly proportional to what? To potential difference, which is PD. So current flowing through a conductor or a circuit, so current flowing in a circuit or a conductor is directly proportional to potential difference, which is a PD that is there. I guess you've seen this. So questions that get to come in an exam, you just need to answer them using these methods. These are simple things that you are supposed to know and be able to answer in an exam. They just give you a question to say a current of, let's say a current, a question comes where they just say a current of what? A current of 2 amps, a current of 2 amps flows. They will just tell you to say flows what? Flows through a conductor, flows through a what? A conductor. It flows through a conductor. I'll say flows through a conductor. The conductor of PD, I'll say the conductor of PD is 12 volts. This is the conductor of PD. Then they will just tell you to say calculate resistance. Calculate what? Calculate the resistance. They will tell you to say calculate the resistance. How then can you calculate this resistance? So calculating the resistance, what we are going to do now, we apply our formula, things that we already know. So the formula that we are going to use here, you know that, okay, resistance is equal to voltage or the PD over what? Over the current. Where this is equal to, what is the PD? That is 12 over 2. Then the answer is 6, then I say ohms. So we get to use this same formula. This is a formula that we are going to be using. This is a formula that we are going to be looking at even as we get to answer questions in an exam. So you understand it that way. If a question was to come, you know, okay, I'm going to do this, and that. We are just applying these formulas. These are simple things. Let's say you've got another example. Let us look at another example. Let's say you've got a question like this. So I just want you to understand this and understand some of these things, even as we get to move forward. This is a short and a wonderful lesson in that I just want to introduce this. Next time, we are going to start with symbols of electrical component. That's where I'm going to start with. So this was just a short lesson. So what if you are given a question to say, find, so they are telling you to say, find the current, find the what? So this is question 2. Find the current. They are telling you to say, find the current. So find the what? Find the current flowing. So find the current flowing. Find the current flowing through. Find the current that is flowing through the what? That is flowing through a 5 ohm resistor. 5 ohm resistor flowing through the 5 ohm resistor that has 20 volts across it. 20 volts across it. So we've got this question. Now they want you to calculate current. If looking at this formula, if you make current the subject of formula, you divide R, you discover that current is equal to voltage over what? Resistance. Where we are going to say, okay, current is equal to, what is the voltage? Voltage is 20. What is the resistance? 5. So what is the answer? The answer is 4 amps. This is the answer. Have you seen? So you just answer questions just like this. You say, okay, you are given this, you make the subject of the formula. If you are given this, you need to make sure that it forms, you calculate a question. I don't expect any person to fail this type of questions in an exam. I don't expect you to fail. I wish you all the best, and even as I give you an exercise. So an exercise may even include some parts that we did previously. Like I've been telling you, these things are interrelated. So these ones are what? Interrelated. What we did can also come in the exercise. You get now to combine them, where you get to use those formulas of charges now. So I'll try to give you a question on that so that I just see if my people are able to understand. So this is where we are going to end from. It was just a short, wonderful lesson. I guess you've learned 1 or 2 things. I'm taking you slowly. I don't want to cover a lot of things at once, then I say, because so far we are almost concluding this particular topic. Our next lesson, then the next one, we are almost done with this. So let me test you if you've understood this by giving you a simple exercise that you are going to do